Welcome to an experiment. I want to see if electrolysis is able to open up this padlock. That's a regular padlock that opens with a key and does not open without the key. I will connect this padlock to the plus pole and the minus pole will go in a salty solution. Then I will submerge this padlock in this salty solution with this part, because that's the side of the padlock where the pin stacks are located, and if the process of electrolysis will eat up enough material from this side, I hope that the springs will come free and all the pins will fall out, and then we will be able to just turn the plug and open up the padlock. Here you can see my setup. I've got a plastic container and inside this curled sheet metal made from copper that is connected to the minus pole via this wire here. So that's the cathode. And from the top hangs the lock. It's connected to this thick steel wire, and connected to the steel wire I have my plus pole. So tomorrow I will go outside and fill up this plastic container with salty water so that only the lower part here of the lock is submerged. Then I will apply voltage to these two connectors, and then we will be able to observe the lock losing material. Okay, back on the next day outside. Let's start the experiment.
In the beginning the liquid was still clear, and so we can observe the process of electrolysis start working. The video is fast forwarded by a factor of 6. But very quickly the liquid became opaque, and so we can only see what happened from the outside. This ugly foam has become thicker and thicker over time and completely disabled my ability to see how much material of the brass has already been removed. Therefore, I was forced to pull out the lock from time to time and inspect the current damage. But before we look at the different stages, we can see the shackle being also exposed to the liquid and to the foam, and we can observe the shackle being eaten away a little bit from the electrolytic process. But now let's look at the different stages of material loss.
It's about 1 hour of electrolysis. We can see the cap from the locking poles exposed, and we can also already see the pin stacks. Here we can see the 1, 2, 3 pins, and here this might be the retaining pin on the very left. So I will continue the electrolysis. So another half an hour of electrolysis treatment. The cap for the shackle or for the locking poles is already gone. So we are making some progress here at least. Just recognized that actually we have more luck, I believe, with the shackle here. This has been eaten away quite a bit and not much is left from this steel shackle. So let's see how this evolves in the near future. So this has been sitting there for about 4 hours or so. I'm pretty sure that you will see a lot of damage on this lock. Take it out. You can see the shackle has been eaten away. Chamber number 2, I believe, is open already. Then number 3 starts to come out, and yeah, the shackle cannot be secured anymore because the shackle has been eaten away a lot.
Here you see the last check for today. The lock was in the electrolytic experiment for about 8 hours in total, and 2 chambers are open now. Chamber number 1 is still closed, and so the plug does not yet turn. You can also see white stuff on the surface of the lock. It's kind of a salt that protects the surface very nicely from further being attacked by the electrolysis. I did my best to scratch away the salt, and then I hung the lock back in the container. I let the power switched off overnight, and when I came back to my experiment on the next morning, I was pretty surprised what has happened.
So I switched off the power overnight, and that's how it looks like when it's sitting there for 8 or 10 hours in rest. And just look how interesting this looks like. We can see almost a connection between the bottom and the lock.
I was pretty tired of pulling out the lock every now and then and inspecting it. So I thought this beautiful picture of salt being developed from the lock downwards and from the bottom upwards is a good end of the experiment. I pulled the lock out as careful as possible and inspected carefully this beautiful piece of art.
Okay, so here is the final result. It almost looks like a piece of art. The shackle was eaten away pretty quickly. The brass was eaten away in the beginning quite okay, but then it stopped, and a salty layer has protected it. And overnight, when I switched off the power, this piece here grow onto the lock, probably kind of a mixture of all different metal, oxide and chloride and whatever. So what I want to do now is take this off and see how much from the Bible has been eaten away. So let's get started. It's pretty soft. Comes off really easily. That's the part where the shackle was. So here we can see the holes exposed. But it looks like not all of them, not all chambers are free. Okay, that's pretty much it, what I can get off with a screwdriver.
I continued the cleanup in a bucket full of water, tried to scratch and wash away as much as possible from the salt, dried the lock and gave it a good brush on the wire wheel brush. And here is how it looks like afterwards.
That's how the lock looks like after some good wire brushing. The brass color is back. The third chamber here was just about to give up, but it's still intact. So that's 1 point for the lock. But the shackle is really nicely eaten away with this tip here. I tried the key, and amazingly it still turns the plug. It even retracts the locking pole. Yeah, as a summary, I wanted to see if electrolysis is able to eat up away enough material from the Bible so that the caps come off and the springs and pins would fall out to be able to turn the plug with a screwdriver. This did not happen. For some reason, the lock was protected by a layer of salt, or I don't know what it was. It was white in color, and it protected this part from further being exposed to the electrolytic liquid. But the shackle here, the steel shackle, was eaten up quite easily and quite quickly. So that's one minus point for the lock. I think that was probably the last experiment with electrolysis. Was quite fun, but it's always a lot of work, and so I think that was the last time I played around with that. Anyhow, I hope you have enjoyed this little experiment, and hope to see you on the next video. Cheers and bye bye.